Hello, pre-calculus type people. Hope you're all having a fantastic day. We're getting into a new unit here on laws of exponents. It's going to be a good day here. Laws of exponents are awesome stuff. We have a couple of things that we need to cover here. This is really going to be a review of Algebra 1 and Algebra 2. All this stuff you already known. B to the m times b to the n is b to the n plus n. So if you're multiplying like bases, add their exponents. If you are raising a power to a power, you multiply their exponents. B to the m over b to the n is m minus n, so you subtract them if you're dividing. It's kind of like saying x to the third over x is x squared. B to the negative m, you flip it to the bottom, make it positive. Anything to the power of 0 is 1. So this is going to be a pretty quick lesson here. Evaluate without using a calculator. Negative 1 to the 12th power. Well, anytime it's an even power, your negative is going to go away, so that's going to be positive 1. So if it's negative 1 to the 42 power, it's positive 1. If it's negative 1 to the 43 power, however, 43, yes, it's going to be odd. Number 2, negative 3 to the 4th, that's negative 3 times negative 3 times negative 3 times negative 3. So negative 3 times negative 3 times negative 3 times negative 3. The negatives obviously are going to go away because there's 4 of them and it's an even number. 3 times 3 is 9 times 3 is 21 times 3 is, 3 times 3 is 9 times 3 is 27 times 3 is 81. So it's going to be 81. All right. Oh, 2/3 to the negative 3. All right, so let's simplify this here. When we have a setup like this, we're going to say that it is 2 to the negative 3, 3 to the negative 3. Multiplication and division are the only times when you can distribute that exponent evenly. So we have to flip these, obviously. We can't leave the exponents negative, so it's 3 to the 3, 2 to the 3, which is 27 over 8. 5 to the 0 is 1. 5 times 5 squared is like saying 5 to the third, which is 125. Yeah, anyway. What's wrong with my pencil? Sorry, got distracted. Okay, 6. Now, 6 is actually an interesting question. I've got 8, 64, and 16. Oh my goodness. I don't like any one of those numbers because none of them are the same. But what's interesting about these is I can actually write 8, 64, and 16 as all base 2. What do I mean by that? Well, what is 2, or excuse me, what is 8 in terms of base 2? In other words, it's like saying 2 to what power gives you 8? Well, that's the third power, right? So 8, there it is, 8 to the third power is like saying 2 to the third power to the third power. That's 2 to the third is 8 to the third power. Times 64 is 2 to the fourth power. No, 2 to the sixth power. 2 to the sixth power. 16 is 2 to the fourth power. That's where the 4 was. So I can rewrite all of these as 2. Now what that lets me do here, 3 times 3, that's going to be 2 to the 9th, times 2, 6 times negative 1 is negative 6, over 2 to the 8th, which is going to be 2, and now since you're multiplying bases, you can add your exponents together. 9 minus 6 is 3, over 2 to the 8. And then you can set up your division. You've got like bases, so subtract your exponents. That's 2 to the 3 minus 8, which is a negative 5, or 1 over 2 to the 5. which is 1 over 32. So laws of exponents help you simplify stuff in such ways it almost makes it ridiculous. 7 says use laws of exponents to simplify. Okay, well 3 times 4 is 12, and then we've got a times a to the third is a to the fourth. Well, that was hard. Moving on. All right. 27 and 45. Now that's actually pretty interesting. 27 and 45 are both divisible by 9, right? So that's kind of like if you divide out 9 here, divide out 9 here, you get 3 over 5. So that's going to be 3 over 5. A to the third over a to the fourth. The a to the third will go away, and that'll take you down to 1. A to the 1 in the bottom. There is no b to the b's in the bottom, so it's just b to the third. C to the fifth over c squared. You can cancel these out. Remember, that's like saying 5 c's over 2 c's. These cancel and leave you with 3 c's. So just some review of Algebra 1, Algebra 2, laws of exponents. All right. Make life easy. That's all this is going to be, is review of Algebra 1, Algebra 2. Negative 3 times x times y squared to the third power. Now, since there are no adding and subtracting, I can actually call this negative 3 cubed x cubed y to the sixth. That's okay. Only because there's no multiplying or subtracting. So this is going to be negative 27 because it's odd. Negative 3 times negative 3 times negative 3 will be a negative 27. X to the third, y to the sixth. If that confuses you, think of it this way. There we go. Negative 3xy squared to the third power is that 3 times. So that's negative 3 times negative 3 times negative 3 is negative 27. X times x times x is x cubed. Y squared, y squared, y squared is y to the sixth. Now, where we start having to rely pretty heavily on these is number 10. A to the x plus 3 times a to the x minus 3. You're multiplying like bases, so you add your exponents. This is going to be a to the x plus 3 plus x minus 3. This is the, put parentheses in here, top exponent plus the bottom exponent. Plus 3 minus 3 will go away, x and x is 2x. None too shabby stuff. And they just get kind of crazier from here. Anytime I see a negative, the very first thing I do is switch everything that has a negative exponent. So I switch everything that has a negative exponent attached to it. My x's here have a negative exponent. My z here has a negative exponent. Now that does not mean, that absolutely does not mean that when I switch this x, I automatically have to switch this one. No. If this was the only one that was negative, then it would be x squared times x cubed in the bottom. But since they're both negative, what the heck? X cubed, y cubed over x squared, y squared, z to the 1. Change this one, change this one, change this one. Why? Because they're negatives. I can have multiple x's in the top and bottom. That's fine. I just simplify it after that. That's okay. X cubed over x squared is going to end up being just x. These will go. That'll knock it down to 1. Same way with these. Knock it down to 1 over z. Okay. Now 12 is a little bit different. On 12, we have 3y to the negative 3, and it's distributing to all three of these terms. So the first one here, 3 and 2, I'll have, this has to go here, here, and here. I'll have 6x to the negative 2, y to the negative 3, plus 3x, y to the negative 2, plus 3y to the negative 1. And that's from saying y to the negative 3 times y to the positive 1. You add them, you get negative 2. Negative 3 plus 2, you add them, you get negative 1. And then come through and correct them. So I've got 6 over x squared y cubed plus 3x over y squared plus 3 over y. And if I wanted to, I could even take it a step farther than that, and I do want to. I can even take it a step farther than that, and I can come up with common denominators and get them all as one fraction. What's my common denominator? X squared y cubed. I can make all of these x squared y cubed. What is this one missing? It's missing an xy, right? X squared y. The denominator down here, I'm missing an x squared and a y. So to make this all one fraction with x squared y cubed, 6 doesn't need bupkis. He's done. He's already got that denominator. 3x needs an x and a y cubed. 3x squared y cubed. 3 needs an x squared y squared. Yahtzee. If you don't understand that, I expect to see you in tutoring. Or Google's a thing. Alright, number 13. 4x cubed y to the negative 6 plus x to the negative 1 y squared negative 3. Alright, so first things first. 4x to the third over y to the 6th. Take that negative value down. Plus, let's distribute this negative 3, so it'll be x to the positive 3 now. Y to the negative 6, so I'll have to correct that. 4x to the third over y to the 6th. Oh my, sorry, got a little out of hand. Press pause, catch up if you need it. Plus x to the third over y to the 6th. I've got 4x to the third plus 1x to the third over the same denominator. Well, that's 5x to the third over y to the 6th. Now, I can only do that because they're both x to the third. They are common terms. Charging through. Number 14. X to the negative 2 minus x squared over x to the negative 1 minus x. This is going to get a little bit complex. Let me separate this here. This is going to get just a teensy bit complex. X to the negative 2 minus x squared. Now, because of this minus symbol, I can't just take the negative 2 and throw it down here. I can't do that because I've got this minus up here. So what I'll have to do is make this a complex fraction. Change x to the negative 2 to the bottom part of this term. 1 over x minus x. And you know we can't leave complex fractions as complex fractions. I need to get rid of these denominators. So I'm going to multiply by the highest denominator I got, see what happens. X squared. Let's multiply the top and bottom by x squared. That's going to end up with x squared times 1 over x squared is 1 minus x to the 4th over x squared over x is x minus x to the 3rd. And I can even go farther than that, and I want to. 1 minus x to the 4th is a difference of 2 squares. It surely is. 1 plus x squared, 1 minus x squared. On the bottom, I've got an x I can factor out. 1 minus x squared. And what do you know? Bob's your uncle. Fast and furious, this lot is. Okay. 1 minus x y to the negative 1. Let's rewrite that as 1 minus x over y. Y to the negative 1 is 1 over y minus 1 over x. Ooh, this one's good. Okay, I need a common denominator between x and y. Well, the quickest way to do it is multiplying xy. Little trick I learned when I was teaching Algebra 1, if you don't like fractions, or if you don't like denominators, get rid of them. Multiply them out. Get rid of them. Who cares? Xy times 1 is xy. Xy times x over y is x squared. Because x times x is x squared, y over y would cancel. X times 1 over y, xy times 1 over y is just x. And xy over x is just y. And you can go even farther, and I want to. In the top, factor out an x. Why? Why not? Now these are pretty close. The only difference is the sign. So let's take a negative sign out of here, and then that whole thing is negative x. What do you know? What do you know? Last one. All right, first off, 1 over a plus 1 over b, all to the negative 1. Okay, this one gets a little funky. You know what? There's another way I'd want to do this. Traditionally, you work from the inside out, but I think I see a different way. Who cares? Join them up together. I cannot distribute this negative 1 until these fractions are 1. One fraction. Okay? I cannot distribute them until these are 1. So come up with a common denominator. Multiply by a over b. I want to be a common denominator of ab. So what's this one missing? B over b. What's this one missing? A over a. And then with the negative sign there, you can just flip the fraction. Yahtzee. Doesn't get much easier than that. The other way, let me just work this out really quick. The other way I was thinking about was doing this. Flipping the whole thing at first, and then doing 1 over a. Yeah, I think that's going to end up being a lot more work than it needs to be. But that's it. Okay, so just a little review on exponents is all this was. Short, sweet, to the point. Have a great day.